Hello everyone and welcome to today's episode of competitive programming, and in today's class we'll be discussing about how to find the divisors, how to check if a number is prime or not, and how to find the greatest common divisor between two numbers using the first plain method, the method which is easy to understand, and also time efficiency method. It's called the equilateral algo. So yeah, and you know what is a divisor? If you don't know what's a divisor, a number which appears in the table of another number is called a divisor. I'm telling it as a divisor. It's actually a divisor. So don't pick point on all this stuff. Yeah. Okay. So I have all the divisors for 120 listed here. I have 1, 2, 3, 4, so on. How do I find a divisor? Basically, the main thing that I have to do is I have to take a variable a. I have to iterate it from 0 to n. The number n for which I want to find the divisor, I iterate it from 0 to n. Okay. And if n mod I is if this is equal to 0, then I can successfully conclude that the number is a divisor. How? I'll take a test case for this. I'll take 120 divided by 6. Does this give me a reminder of 0? Yes, it gives me a reminder of 0, so I can conclude that the number is a divisor. I take 121.9. Does this give me a reminder of 0? No, it does not give me a reminder of 0, and thus I can conclude that the number is not a divisor of 120. So this is the only thing that you need to follow for finding the divisor of a number. So I'll write the code here. I'll take it as int I, int n. And you might ask me, I'm iterating from I to n. Why not n plus 1, n plus 2? Because if you see here, the divisor of 120 are till 120. There's no 121, 122. No, you will not find a number whose divisor is greater than the number itself. Okay, so that's the thing that you need to see here. And for I equal to 0, I should be less than or equal to n, I plus plus. And wait, if n mod I equal to 0, see out I. Do you think this code is correct? For me, it looks absolutely correct. But do you think it's actually correct? No, it's not. It's going to give me an error here. Wait. Non-zero exit code. Actually, we start from 0. If you know basic math, x by 0 is undefined or infinity. 0 by x is equal to 0. So I cannot start it with 0. That's a very basic error. There's no issues if you commit this error once. But don't forget this, okay? You start from 1. Yeah, so now I'll get all the divisor 1. Let's go with a very massive number. Let's go with 1140. And then, wait. Sorry, I put a comma here. I forgot another one. Yeah, so I've got all the divisors of 140. And if I have to check if a number is prime or not, I take another variable as count, and I increment count whenever I find a divisor. I just write it here, count equal to count plus 1. If, and then I add another if case, if count equal to 2, because 1 is a divisor of each and every number. You find 1 in the table of each and every number and the number itself. If there is only these two numbers, that I can conclude that the given number is prime. So finding prime is also very easy in this case. I'll just take another variable, int count equal to 0. Okay, and in here only I add count equal to count plus 1, and I exit this loop if count is equal to 2 is I'll say exactly 2. Yes, I need it to be exactly 2. You can't say less than or equal to 2, because a number has two more than two divisors. It cannot have one divisor. Only one has one divisor. 2 has 2 comma 1, 3 has 3 comma 1, 4 has 2 comma 4 comma 1. Okay, so a number has at least on a minimum two divisors. It cannot be less than 1. So if count equal to 2, see out, sorry, excuse me, see out, the number is prime. I exit this loop, else see out, the number is not prime. Okay, let's check this out. Okay, I go down, the number is not prime. If I give a prime number, let's say 7, the number is prime. Let us take another prime number, 11. The number is prime. Wonderful. So we are going to find the GCD. GCD stands for greatest common divisor. And if you do not have any idea about GCD, the GCD of 45 and 30, you pick the common divisors and you just keep on multiplying them. So the common factor, it's also called the HCF. This is also called the highest common factor, and GCD. These both are the same, so don't be confused. Okay. So you pick the highest common factor between the two numbers. If you don't know basic math. Okay. How I find this is I iterate a loop from I from 0 to n. I do not take it 0. I take it 1. Why? Something by 0 is undefined. Sorry, not I. Something by 0 is undefined, and 0 by something is 0. So I take a loop from 0 to n. This n here, this is the minimum of n1 comma n2 because you find GCD between two numbers. Okay, so why am I going with minimum of n1 comma n2? I'll show you the GCD of, let's say, 30 and 6. Let us find. Okay, 6 is 1 2 3 6 itself. GCD of 30, I go 1 2 3 6, say 30 itself, and then 15 twos are 30, 3 tens are 30 10, 6 fives are 35, and what else is there? Yeah, nothing else is there. Okay, I don't find it in 20. Yeah, so you can see the numbers which are greater than 6, minimum of these two is 6. Okay, you can see the numbers which are greater than 6. These cannot be the GCD because these do not appear here, right? So we cannot consider these for finding the GCD. Yes, you can tell 3 into 5, that's a different thing, but you need to take the minimum of n1 and n2 because you cannot find the numbers which are greater, multiples of the greater number in the lesser number. If you didn't understand what I'm telling, please rewind or feel free to ask me in the comment section. The reason why I take the minimum of a comma b or n1 comma n2 is because if a is greater than b, I cannot find divisors of b in a. So it is absolutely waste of iterating there. So that's why I go with minimum of n1 comma n2. Let's write the code here. int i int I in n1 comma n2, c in n1 and n2, and then for I is equal to what? 1. I should be less than or equal to minimum of n1 comma n2 I plus plus. And uh, if do I go with if? Yeah, I do not know the amount of times is going to iterate. Now I just find the divisor. How you find the divisor? N1 mod of I equal to 0 and N2 mod of I equal to 0. I can tell that. I'll take a variable to store the GCD here. Int GCD equal to 0, GCD equal to I. Yeah, so see out GCD. It's going to give me 8. If I go 16, 24 and 18, GCD 6. Okay, so this is the basic program to find the GCD. Equilateral algorithm. For instance, I were to remove, there's a very high level algorithm in math. It's called the equilateral algorithm. It states that the GCD of a comma b is equivalent to GCD of a minus b comma b, where the condition is that there is a condition that a should be always greater than or equal to b. And in programming or in mathematical terms, I can rewrite this as GCD of a mod b comma b. Why can I rewrite it like this? Let us check. Okay, I have an example here. I'll erase everything here. Okay, if I were to find the GCD of 12, 1220 and 516, the formula states that GCD of a minus b comma b, where a is greater than b, this should be greater than this. So 1220 minus 516, so on, and if you keep doing, you get GCD of 0 comma 4. Now if there is a number remaining, no, if there is a 0 and there's a non-zero number, the GCD is always a non-zero number. I get 0 here, the GCD is always non-zero. It's a mathematical logic. If you want to dive deep, yeah, sure, you can dive deep, but you can say GCD of a comma b is equal to GCD of a mod b comma b, where a should always be greater than b. Now if I were to write this in programming, remember, if you're finding the GCD, right, if this is 0, then this is your GCD, and if this is 0, then this becomes your GCD. The non-zero term becomes your GCD while you're finding the GCD by subtraction, as I said. Okay, so don't get confused. If you have any doubts, please don't feel shy to ask them in the comment section. I'll clarify them, no issues. So I changed this code a bit. I'll change it a bit from where yeah, I'll change it from here. While n1 should be greater than 0 and n2 should be greater than 0. These both should be greater than 0, or you can tell that not equal to 0. While n1 is not equal to 0 and n2 should also be not equal to 0. Because if they are 0, the other, so for instance, if I tell you if n1 is 0, as I said here, n1 is 0, n2 becomes my GCD. And if n2 is 0, n1 becomes GCD. So I iterated, so I found iterated till both of them are not zeros. If n1 is not equal to 0 and n2 is not equal to 0, I iterated. Uh, the condition here within this loop is always true. That's why you use a while loop again. If I can tell that if n1 is greater than n2, I go n1 equal to n1 mod n2. The reason I do this is because, as I told you, GCD of a comma b is equal to GCD of a mod b comma b, where a is greater than b. Here I am telling that n1 is greater than n2, therefore n1 becomes n1 mod n2. A mod b comma b. This is my GCD. Okay, so I keep on doing this again and again, again and again and again and again and again, and this is the format that I'm following: GCD of a mod b comma b. This is for a greater than b. This is what I've written here in code. This is what I've represented here in code. If a is greater than b, if a is greater than b, n1 equal to n1 comma n2. That's it. Nothing more. That's all I've written there. And what I'll do is I'll be clever and I'll just copy paste this code again. And I'll just write else in this case. Else I'll just take n2 equal to n2 more n1. Okay. Now I exit out of this loop, and if n1 equal to 0, what is my GCD? Cout n2, cout n2. This is my GCD. Else cout n1. This is my HCF. GCD and HCF are the same. You do not need to get confused. Okay, let's run this. Yes, that's about it. I made a bit of a change here. You can just go with if case instead of else. It's your wish, whatever you wish for. So that's about it. It gives me a warning, but don't be like, no, don't be afraid of that warning. It's basically telling that I haven't used this at this time. Yes. So that's about it. Thank you. Have a nice day.